Hello there. I welcome you to this presentation on thermal power plants. The word power plant means a facility where the electrical power is generated. In the automotive jargon, power plant means an internal combustion engine meant for powering the vehicles. But in this program, let us focus our attention on thermal power plants. And when it comes to power plants, there are two major categories, namely conventional and the non-conventional power plants. In the conventional, we have thermal power plant, hydro power plant, nuclear power plant, diesel engine power plant, and gas turbine power plant. On the other hand, in the non-conventional category, we have solar power plant, wind energy power plant, geothermal power plant, ocean thermal energy conversion power plant, and tidal energy power plant. The conventional power plants are very common, and we'll be able to see them around our places. That's why they are called as conventional power plants. Now let's focus our attention on the thermal power plants. The principle that is employed in the thermal power plant is very simple. You raise steam in a pressure vessel called as boiler by burning a fossil fuel. The steam that is generated will have thermal energy, and this thermal energy will be transformed to mechanical energy in a prime mover called as turbine. The mechanical energy that is produced by the turbine will be converted to electrical energy in a generator that is coupled to the turbine. And that's how the thermal power plant works. And this slide shows you the typical layout of a thermal power plant. At the outset, when you see it looks more like a circuit diagram. It is. It shows how the different components are laid out and how they are interconnected with each other. And when you see this circuit diagram, it looks somewhat complex, but when you decipher the different parts of the circuit, and then when you look at it, it will be easier for understanding. And as far as the layout is concerned, a thermal power plant has four major circuits. They are the coal and ash. We'll see all these four circuits one by one, and at the end we'll be able to understand the general layout of the thermal power plant. Coal is available in coal mines that are spread across the country in different states. Normally, these coal mines are located in states like Assam, Jharkhand, Chhattisgarh, Odisha, Maharashtra, Madhya Pradesh, and in the south we have mines in Telangana, Andhra Pradesh, and Tamil Nadu. Since these power plants are spread across the country, you have to move the coal from where the coal is mined to the place where it is utilized. That is the thermal power plants. And when we talk about thermal power plants, for its operation, we require huge quantities of coal. To put that in perspective, a thermal power plant which generates 1000 megawatts requires around 10,000 tons of coal each day for its operation. So, for its operation, a huge amount of coal is required, which has to be moved from the coal mines. And if the power plant is closer to the sea, you can move the coal by means of ships, by means of cargo ships. And from the ships, the coal could be transferred to the power plant. And if the power plant is located closer to a river network, you can take advantage of it You can the coal could be moved by means of barges in bulk in huge quantities. And if a sea facility or if a river network is not available, you can move the coal by means of trains. And if the power plant is located closer to the mines, you can move the coal by trucks. So this is how you move huge quantities of coal to the power plant premises. Once when it comes to the power plant premises, the coal has to be unloaded from these ships or train or trucks. For that, several mechanical handling equipments are used. And the first mechanical equipment that is used for unloading the coal is called as a grab bucket. This grab bucket could be used to uh, pick up and deliver the coal from trains or trucks or ships. So the coal could be transferred through a smaller distance by means of these grab buckets. And one of the most popular methods of transferring the coal is by means of belt conveyors. These are very popular and you can transport coal over a very large distance. The mechanism is very simple and it's quite reliable as well. And when coal has to be shifted to a certain height, you can transfer the coal could be transferred by mechanisms called as bucket elevators or bucket conveyors. The coal would be picked up from a lower level and it would be delivered at a higher level where it is required. And if the coal has to be moved through a shorter distance, we can use what is called as a screw conveyor. A screw conveyor could be used to transport coal in a horizontal direction for a short distance. And the next option that is available is a skip hoist. If the coal is to be taken to a higher level, we can use this particular coal handling equipment. The coal has to be loaded in a bucket-like arrangement called as a skip, and it will be carried over the rails. And once when the skip reaches the top, it will be tilted, and the coal will be just unloaded at a higher level. And once when the coal is unloaded, it has to be stored somewhere inside the premises of the power plant. It could be stored both in the open as well as in a covered storage. If it's stored in the open, normally that will be uh, arranged in the form of stockpiles, as we could see in this diagram. Or else it also could be stored in closed shelters, like what you see here. There are some problems related with storing the coal in the open. Coal has a very unique property. Coal, when you leave it in the open, it undergoes an exothermic reaction, and once when this temperature reaches its ignition point, the coal will spontaneously ignite or auto ignite and will start burning. To prevent this, you have to cover this coal with a blanket of some material, either sand or some other material, or the coal could be stored in underground trenches filled with water, and the coal could be stored in those trenches. And when the coal is required in the power plant, the coal could be taken and then processed, prepared, and then it could be taken to the uh, boiler. Or also it could be stored in the sheds in closed bunkers. So these are the methods by which you store the coal. The next stage in the coal and ash handling is the coal preparation. And when we say preparation, it means cleaning. The coal that is excavated from mines will not be very clean. It will have impurities and other unwanted elements in the coal. So those have to be removed. And a few mechanical equipment are available for cleaning the coal. The first is called as a water jig. Basically, this is flushing the coal with the water, wherein the water would remove the impurities. The next mechanical facility that is available for cleaning coal is a concentrating table. Basically, that's a table which agitates back and forth, and the coal as well as the dust, because of their weight differences, they get segregated, and the coal could be uh, removed. The third method available for cleaning the coal is by once again washing in equipments called as hydrocyclone. So inside a chamber, the water will be churned, and the coal will be introduced inside the churning water, and this water would just carry the impurities. The water could be filtered, cleaned, and once again fed back to the hydrocyclone for further cleaning purposes. And after cleaning, the coal could be stored in some temporary storage. And once when it is about to be fed to the boiler, the coal has to be once again processed. The coal that comes from the mine will be of a larger size. It will be in the form of chunks, or it will be like boulders. They have to be broken down to smaller sizes. Once again, that's based on the type of boiler that is used in the power plant. And most boilers, they require coal in the form of powder. And for that, mechanical equipments called as pulverizers are used for crushing the coal which is in the boulder form to a consistency of fine powder. The different crushing equipment that are available are ball mills, hammer mill, ball and race mill, and the bowl mill. So these mills, they help in crushing the coal into a fine state, something like a talcum powder. And once when the coal is ground, it has to be taken to the boiler, and conveyor could be used to transfer this coal to the crushed coal to the boiler, or in many cases, in many power plants, the air that goes to the combustion chamber will be used to flush the powdered coal particles from these crushers to the combustion chamber of the boiler. And once when the coal reaches the boiler, it mixes with the air, it burns, and ash is left behind. There are basically three different types of coal, namely anthracite, bituminous, and lignite. Anthracite has the highest calorific value and has the least ash content. And this is followed by bituminous, which has a relatively lesser heating value and has relatively higher amount of ash content. And this is followed by lignite, which has the highest ash content and which has the least calorific value. The choice of these coal is once again dependent on their availability and their cost. If lignite is used, a lot of ash should be generated, and this ash has to be removed from the boiler from time to time. If you take the case of a super thermal power station which produces 1000 megawatts, as said earlier, approximately 10,000 tons of coal would be burnt per day. And if the coal used is lignite, nearly 40% of the fuel will come as ash. So if 10,000 tons of fuel is used, we get 4,000 tons of ash. So that's a very huge quantity. And this ash will be in the form of clinkers. So um, it will be like a glowing sparkler. This is highly corrosive, and this can damage the internal parts of the boiler. So the ash has to be cooled and moved from the boiler grate or the boiler furnace. For that, we use several mechanical handling systems for removing the ash. When we say mechanical handling, it means conveyors, metallic conveyors which run beneath the grate of the boiler furnace. The other option that is available is a hydrojet. We have a running stream of water, and the ash that falls down from the grate would be cooled and then carried away by the water jet. The ash upon cooling forms a thick mass, something like a clinker, and it will be filtered and then will be taken out. The third method available is a steam jet method of ash handling. So in this, high pressure, high velocity steam jet is used for flushing the ash particles from beneath the boiler. These are some of the methods that are available for handling the hot glowing ash that comes from the boiler. And once when the ash gets cooled, it has to be stored in some place. Normally, there is no separate shelf for this. The ash should be just stored in an open yard. Earlier, the final stage in coal and ash handling circuit would be the ash disposal. Earlier, the ash uh, used to be a headache for the thermal power plant. Huge quantities of ash have to be discarded. The power plants, they were struggling to just dispose this ash. But presently, this problem has been circumvented by uh, some other arrangements. These ash, they are taken for landfill. These ash, they will be taken back to the mines from where they are excavated, and the cavity that is left behind after the excavation would be just filled with these ashes. And once again, the land mass would be restored for some other purpose. And the second way of ash disposal is you just use the ash for making some construction materials. These days, civil engineers, they have found ways to make bricks from the fly ash, that is ash that comes from the boiler. The bricks that are made out of this fly ash, they are compatible with with the normal clay bricks, and in some cases they are even superior than the normal clay bricks in terms of their strength and water retaining properties. So these days, the ash disposal is no longer a problem. The manufacturers of ash bricks, fly ash bricks, they just come down to the location of the power plant and they take the ash for their use. We have just seen the coal and ash circuit. The next circuit that we have to see is the water and steam circuit. The layout of the power plant has been selectively masked to reveal the circuit that is of interest, so that once when we understand this circuit, collectively putting all the circuits together, it will be easier for us to understand the complete layout. The circuit starts with the boiler. Boiler is the heart of the thermal power plant. The boiler is basically a pressure vessel meant for raising steam by burning a fossil fuel, namely coal. The steam that is generated in the boiler will be of wet or dry state. Normally, in a thermal power station, A wet steam is not desirable because the water particles that are larger than the steam could go and hit the turbine blades like bullets and can cause damage to the turbine blades. Besides, a superheated steam can carry a lot of thermal energy, and when there is a good amount of thermal energy in the steam, more amount of mechanical energy could be derived in the turbine. And that's the reason why a superheated steam is required for use in the case of a thermal power plant. For doing the superheating, we are using a mechanical component called as a superheater. Basically, this is a heat exchanger which operates by taking the heat energy in the flue gas and giving it to the steam that's coming from the boiler. The steam that leaves from the superheater will be in the superheated state. The superheated steam from the superheater will go to the turbine, will be expanded in the turbine. So the thermal energy that is contained in the steam will be converted into mechanical energy. The steam that comes from the turbine will be of low temperature and low pressure, and this steam has to be condensed. The reason being, a boiler that is used in a thermal power plant will use several tons of water for its operation. And if this steam is left to the open, you have to continuously supply a lot of water to the boiler permanently, which is not possible in many situations. So the steam that comes from the turbine is normally condensed back to the liquid form, and this is called as condensate. The low pressure, low temperature steam coming from turbine is condensed in the condenser. The condenser is also a kind of heat exchanger. There are different varieties. So this is an indirect heat exchanger wherein the heat of steam is exchanged to the cooling water. Once when the steam gets condensed and becomes a condensate, it is taken to a storage tank called as hot well. And from the hot well, the water is once again pumped back to the boiler by a pump called as a boiler feed pump. The boiler feed pump has to supply the water at a pressure higher than the pressure that is prevailing in the boiler. The boiler water that goes from boiler feed pump will pass through what is called as an economizer. An economizer is also a heat exchanger which which preheats the water that goes to the boiler. The reason why this is done is inside the boiler, the water will be at a very high temperature, and the water that goes from the hot well will be at a temperature almost that's closer to the atmospheric. So this cold water, once when it enters inside the boiler, could reduce the temperature of water that is inside the boiler, and hence before being supplied to the boiler, it will be preheated in a heat exchanger called as economizer. So the preheated water enters the boiler, and once again the cycle continues. This is a closed cycle, so the working fluid will not be allowed to go outside the system. So in part of the circuit, the working fluid exists in the form of steam, and for the rest of the circuit, it exists in the form of water. So with that, the water and steam circuit is complete. Now we shall see the third circuit, namely the air and flue gas circuit. This is the air and flue gas circuit. The circuit basically starts with a forced draught fan. The term draught means the pressure difference which is required to move the column of air through the different parts of the circuit. Air has mass. the density of air is 1.4 kilogram per meter cube, which means each 1 meter cube of air would weigh 1.4 kilogram. So when huge quantities of air is about to be moved through the system, a lot of inertia would be there in the air, and some external force is needed to push or propel this mass of air through the different parts of the circuit. So for doing this, we have two different fans, namely the forced draught fan and the induced draught fan. And this forced draught fan does the act of pushing the air through the different parts of the circuit. The air that is forced by the forced draught fan enters inside the air preheater, gets preheated. The air preheater is a heat exchanger which exchanges the heat from the flue gas to the cold air that's going to the boiler. The air preheater, superheater, and economizer are all called as accessories. These are called as accessories in the sense, even without their presence, the boiler will be able to run without any trouble, but the efficiency of the boiler would be less. With the presence of air preheater, superheater, and economizer, the efficiency of the boiler would be improved, and that's exactly the reason why these accessories are installed in any thermal power plant. The hot air that comes from the air preheater goes inside the boiler. It burns with the fuel and flue gas would be generated. Much of the heat that's generated by the burning of fuel is transferred to the water for conversion to steam. Nearly 60% of the heat that is generated is used for the generation of steam. The flue gas that comes out of the boiler will still have thermal energy, and part of this thermal energy will be recovered in the superheater. The superheater transfers the heat from the flue gas to the steam that comes out of the boiler, which goes to the turbine. By doing so, the dry or the wet steam will be converted to superheated steam. The flue gas that comes out of the superheater will be taken to the economizer, wherein the heat of the flue gas will be transferred to the cold water that is going to the boiler. And after the economizer, it is once again uh, taken to the air preheater, wherein the flue gas that comes from the boiler will be preheating the air that's going to the boiler. By the time when the flue gas comes out of the air preheater, almost all of the thermal energy that is in the flue gas would have been absorbed in these accessories. And the flue gas that comes out of the system will have a lot of impurities, lot of pollutants, and these pollutants and the impurities will be removed from the flue gas by means of the dust collection systems and what is known as ESP or electrostatic precipitator. So all these systems, they just remove the impurities as well as the harmful pollutants in the flue gas. And after the electrostatic precipitator, the flue gas will be sucked by the induced draught fan. The induced draught fan basically induces a negative pressure on the system. So it basically pulls the flue gas through the system. The forced draught fan, on the other hand, it just pushes the air through the system, and the induced draught fan, it pulls the flue gas from the system so that there would be a balanced movement of the air and flue gas within the system, and hence this particular system is called as a balanced draught system. As you could see, part of the circuit is bluish in color, which means this part of the circuit has air, and the remaining part of the circuit is red in color, which means that this part is occupied by the flue gas. So this is an open circuit, and the circuit ends with the chimney. The hot exhaust gas of the flue gas, it has to be led to the atmosphere at a much higher height. If it's let out at the ground level, it will cause disturbance to the um, people surrounding that thermal power plant. So the flue gas has to be let out at a higher altitude. For that, we use chimneys. So chimney is basically a tubular structure which is very tall, and certain cases these chimneys they can reach heights up to 300 feet. And by having a very tall chimney, natural convection would be induced by the chimney. So the combined action of the forced draught and the induced draught fan, along with the natural draught that is created by the chimney, will move the air as well as the flue gas throughout the system, and we have a balanced movement of the air as well as the flue gas within the system. And with this, the air and flue gas circuit is complete. Next, we shall move on to the fourth circuit, which is the cooling water circuit. So in the cooling water circuit, we have components like the condenser, the circulation pump, and the cooling tower. So the condenser is basically a heat exchanger, a indirect type of heat exchanger which exchanges the heat of the steam that's coming from the turbine to the cold water that passes through the circuit. So when the heat is exchanged, the cooling water will become hot and the steam will become a condensate. The hot water has to be cooled so that the cooling in the condenser would be efficient. So for cooling the water has to be taken to a arrangement called as a cooling tower. A cooling tower is basically a very huge structure which is hollow on the inside. Normally, the shape of this cooling tower would be hyperbolic. The reason being, it will channel the flow of air from the bottom towards the top. The hot water that's coming from the condenser will be taken to a certain height inside the hyperbolic tower where the velocity of gas stream would be higher. As you could see, the cross-sectional area at the bottom would be higher, and somewhere along the height, the cross-sectional area would be lesser. And this would mean an increased velocity of air in this particular cross-section at this height. So this resembles a nozzle-like arrangement wherein the diameter here is higher and the diameter here is lesser. So naturally this will funnel the movement of air through the duct-like arrangement. This would increase the velocity of air, and the place where the velocity is maximum, the water is sprayed from the top. The cold air that goes mixes with the hot water directly. So this is a direct uh, contact type of heat exchanger, wherein the hot water comes in contact with the cold air directly. So when the air becomes hot, it becomes lighter and it ascends up. As and when it ascends up, it leaves a negative pressure at the bottom. So the cold air from the outside, they rush through the openings at the bottom and they will move towards the top, ensuring a natural convection. So the water gets cooled, water spray is sprayed at the top, it gets cooled, gets collected at a pond at the bottom of the cooling tower, and this water which has become cold now will be circulated by a circulation pump to the condenser, and the cycle would be complete. The circuit would be complete. Normally, the circulation pump will be of a higher capacity. As you could see, the size of the circulation pump would be very large, driven by very powerful motors, because it has to handle a huge quantity of water. So with that, the cooling circuit is complete. And now when we look at that complete circuit, it will make some sense. It will be easier for us to understand. So this part of the circuit is the coal and the ash circuit. And this part of the circuit is a water and steam circuit. And this part of the circuit is a air and flue gas circuit. And this part of the circuit would be the cooling water circuit. So by now, we have come to a complete understanding of the entire circuit of the power plant. So that is about the working of a steam power plant. Now let us try to see the merits and demerits of a thermal power plant. So when we talk about the merits, you can say that the life of the plant is normally higher, roughly around 25 to 30 years. And when you compare the cost of installation with the other power plants, namely the hydroelectric power plant or nuclear power plant, the initial cost of the power plant is comparatively less. And another major advantage of this thermal power plant is its suitability for varying load conditions. The demand on the grid keeps varying from time to time, and the power plant should have the capacity to cater to the varying demands of the grid. And this is a power plant which can take that varying load condition with ease. And when you just compare with other power plants, the pollution is lesser, because the flue gas, before being let into the atmosphere, all the pollutants and the harmful gases, they are removed and contained. Another advantage of the thermal power plant is you can have unskilled operators to operate the plant. Another major advantage of the thermal power plant is the power plant does not depend on a very major source of water. Just because each and every circuit is a closed circuit, the huge quantity of water that is used in the boiler and the huge quantity of water that is used in the cooling circuit, they are all used over and over again. So you need not replenish it with water from some water source. Since these power plants have the advantage of being located closer to the load center, you can have a minimal transmission lines, and this would result in minimum transmission losses. So that's a main advantage of a thermal power plant. They are not affected by the vagaries of nature, and they have the flexibility to be installed anywhere as required. Normally, these are located closer to the load centers, meaning the place where the electricity is being used. So those are some of the positive factors that speak in favor of the thermal power plant. And when it comes to the demerit, speaking of demerits, the thermal efficiency of a thermal power plant is very less. Since these are all machineries which operate on heat, and heat being a low-grade energy, the efficiency of these power plants are normally lesser. The efficiency will be anywhere between 25 to 30%. And bringing a thermal power plant to an operating condition from a cold condition normally takes more time. It takes several hours for a thermal power plant to bring from the cold condition to the operating condition. More cooling water is required. The area that is required for the installation of the plant is also very high because of the large number of components in the power plant. And besides, a large space is required to accommodate the coal as well as the ash. The ash handling is also a headache in certain cases. And if the power plants are not located closer to the coal fields, they are not economical in the sense a lot of cost is involved in transportation of the coal. The manpower required is also more because there are many number of components, and for large units normally the capital cost is more. Those are some of the demerits of a thermal power plant, but invariably what we find is almost 60% of our nation's demand is met by the thermal power plants just because of the reason they are more robust, they are more reliable, and they could operate in any adverse weather conditions, and they have the flexibility to be located in any location we want. So with that, we come to the end of this presentation on thermal power plants. Thank you.